Hello guys, how are you? I hope you will be fine. So guys, let's start. My today topic is solutions of liquids in liquids. The solutions of liquids in liquids may be divided into three classes. First is completely miscible liquids. Liquids like alcohol and water are alcohol and either mix in all proportion. However, the properties of such solution are not strictly addictive. Generally, the value decreases on mixing, but in some cases it increases. Heat may be evolved or absorbed during the formation of such solution. This type of solution can usually be separated by friction distillation. Second is partially miscible solution. A large number of liquids are known which dissolve into one group up to limited extent. For example, either C2H5 single bond 0 single bond O single bond C2H5 dissolves water to the extent of the about 1.2% and water dissolves either up to the extent of about 6.5%. As the mutual solubilities are limited, the liquids are not partially miscible. On shaking, equal volumes of water and either two layers are formed. Each liquid layer is saturated solution of other liquid. Such solutions are called conjugate solution. The mutual solubility of these conjugate solutions is affected by temperature changes. Typical examples of such systems are: first is A is phenol water system, triethylamine water system, nicotine water system. First is phenol water system H2O plus C6H5OH. The example of phenol in water is interesting. If equal volume of water and phenol are mixed together, they show partial miscibility. It has been observed that around room temperature, phenol will dissolve in a lot of water, giving us the upper layer, and water will dissolve in a lot of phenol giving us the lower layer. At 25 degrees Celsius, the upper layer is 5% solution of phenol in water and the lower layer is 30% water in phenol. These two solutions are conjugate solutions to each other. The lower layer has a great density due to the great percentage of phenol. Water acts as a solute in the lower layer while phenol is a solute in the upper layer. When the temperature of the water phenol system is increases, the compositions of the both layers changes. Water starts traveling from upper layer to the lower layer and phenol travels from lower layer to upper layer. When the temperature of the system approaches 65.9 degrees Celsius, a homogeneous mixture of two compounds is obtained. This homogeneous mixture contains 34% phenol and 66% water. The temperature of 65.9 degrees Celsius at which two conjugate solutions are merged into one another is called critical solution temperature or upper consolate temperature. Some other partially miscible pairs of liquids have their own consolate temperature with definite composition. For example, water aniline system has a single layer at 167.0 degrees Celsius with 50% water. Methanol cyclohexane system has consolate temperature of 49.10 degrees Celsius with 29% methanol. Third is liquid partially immiscible. Those liquids which do not dissolve into each other in any proportion are immiscible. Examples: first is water and benzene H2O plus C6H6, and second is water and carbon disulfide H2O plus CS2. And next, ideal and non-ideal solution. When two or more than two liquid substances are mixed, the solution may be ideal or non-ideal. To distinguish between such solutions, we look at the following aspect. First is, if the force of attraction interactions between the molecules of different components are same as when they were in the pure state, they are ideal solutions, otherwise non-ideal. Second is, if the volume of the solution is not equal to the sum of individual volumes of the components, the solution is non-ideal. Third is, ideal solution has zero enthalpy change as their heat of solution. And last is, if the solution obey Raoult's law, then they are ideal. This is one of the best criterion for checking the ideality of a solution. Let us first study the Raoult's law and then try to understand ideality of solution, the process of Russian distillation, and the formation of azeotrophs.